This video will examine the structure and function of macromolecules, the lipids. Lipids are composed of carbon, hydrogen, and oxygen atoms that form long chains of basically carbon and hydrogen. The building blocks of lipids can be fatty acids, glycerol, choline, phosphate, and terpenes. Lipids are used for long-term energy storage. They store about 5 times as much energy per gram as a carbohydrate does. They are important parts of membranes because, being nonpolar for the most part, they do not allow water or water-soluble materials to pass through them. This allows them to form waterproof coverings. Some lipids are also important because they function in organisms as hormones. In this video, we will be examining 3 different kinds of lipids. The lipids that are composed of fatty acids, the lipids that contain glycerol, and the lipids that do not contain glycerol. Before looking at the lipids that consist of fatty acids, we have to look at what makes up a fatty acid. The first component of a fatty acid is a very long hydrocarbon chain. You can see the hydrocarbon chain right here. It can usually consist of a straight chain of carbons where each carbon will have 2 hydrogen atoms bonded to it. The terminal carbon on the hydrocarbon chain will have 3 carbon atoms bonded to it. Fatty acids are monocarboxylic acids because they have a single carboxyl group. So as you look at this now, to make a fatty acid, this carboxyl group will be on one end of the chain. So as we look at a whole fatty acid, what we would see is the hydrocarbon chain portion. This is a portion that is definitely nonpolar. This is a portion that is hydrophobic. It actually avoids water. It pushes itself out of the water. The other part of the fatty acid is the carboxyl group. The carboxyl group, because of the double bonded oxygen and the hydroxyl group, is a polar moiety. It is hydrophilic. It can form hydrogen bonds with water molecules, and water molecules can associate its positive end with the hydroxyl group, which when dissolved in water can lose the hydrogen ion. So it is hydrophilic. This becomes very important in terms of some of the properties of lipids or fatty acids themselves. We know that lipids consist of fats. Lipids also consist of oil. So what is the difference between a fat and an oil? Well, basically a fat is a lipid that is solid at room temperature. And usually that means that it has a hydrocarbon chain or chains that are more than 10 carbons long. Examples of solid fats are, at the top, we have butter. Beneath the butter, we have lard, and then beneath the lard, we have a manufactured form of fat, which is oleomargarine or oleo. Oleo is made from unsaturated fats, which are usually liquid at room temperature. So a fat, once again, is a solid lipid at room temperature. Oils, on the other hand, are liquid at room temperature. Oils have 2 structural similarities. They either have a hydrocarbon chain that is less than 10 carbons long, or they are unsaturated. If we look more closely at the fatty acids, you will see that there are 3 basic types of fatty acids on their own. Okay, remember again, fatty acids consist of a hydrocarbon chain, which is nonpolar and hydrophobic, and a carboxyl group, which is polar and hydrophilic. The first type of fatty acid is what we consider a saturated fatty acid, which is similar to our generic example at the top. Saturated fatty acids have no carbon-to-carbon double bond. And because they have no carbon-to-carbon double bonds, Each carbon is holding the maximum number of hydrogens, which is why we call it saturated. It is saturated with hydrogens, so that the terminal carbon has 3 hydrogen atoms associated with it, and every carbon within the chain has 2 hydrogen atoms associated with it. An unsaturated fatty acid has at least 1 carbon-to-carbon double bond within the chain. And because of that 1 carbon-to-carbon double bond within the chain, it has less than the maximum amount of hydrogen. And you might have heard about this in the news, because in diets, they've been talking about something that's called a trans fat. And if you remember to your organic chemistry in Core Chem, when you have a double bond, when the 2 atoms or moieties attached to the carbon are on the same side of the double bond, that is called a cis configuration. If, on the other hand, we were to move this hydrogen from here to this side of the double bond, where the hydrogens are on opposite sides of the double bond, that is a configuration that is known as a trans configuration. Now, trans fats have been shown to be related to some circulatory disorders. Trans fats were originally used in foods because they made the lipids have a longer shelf life. Finally, the third type of fatty acid is the polyunsaturated fatty acid, where we have multiple double bonds. And again, in this case, both of these. To review, saturated fats and fats that are greater than 10 carbons or more are solid at room temperature. In general, unsaturated fatty acids or fats that are 10 carbons or less are liquid at room temperature, and those are what we call oils. Solid fats are what we call fats or waxes. Fatty acids are an important component of soap. Soap, as you know, is what we use for cleaning. Soaps are salts of a fatty acid, and right here, most soaps are composed of sodium salts or potassium salts. And what you have is the sodium is attached through an ionic bond to the negative charge on the carboxyl group of the fatty acid. Now, what's preferably used would be a fatty acid that is an unsaturated fat, because that will give it slight solubility in water. When dissolved in water, what happens is the hydrophilic side is attracted to the water, and it arranges itself so that the hydrophobic side of the fatty acid is pushed up out of the water, or forms what is called a micelle. Okay, so 2 things happen when a soap is dissolved in water. The hydrophilic part of the fatty acid will align itself towards the water. The sodium ions will be dissolved in the water. What can happen is, as the soap is dissolved to begin with in the water, it will form, the fatty acid part of the soap will form this circular-like structure called a micelle, where what the hydrophilic sides of the fatty acid is aligning itself so that it protects the hydrophobic side from the water. What occurs is the dirt and the greases get caught inside in the hydrophobic hydrocarbon chain, and eventually that carries away the dirt, which is the way soaps clean. So here is a larger picture of the micelle in slightly 3 dimensions. When you are finished cleaning, you will notice that at the top of your tub, if the fat from the soap is lighter than water or less dense than water, it will form a film on the top. When you drain the water, that film often forms your bathtub ring.